Conduction. What do you mean by conduction? It is a process in which heat is transmitted from one part of a body to another part of the body, that is, from high temperature to the lower temperature, without any actual flow of matter. Factors on which conduction of heat depends. On which factors the conduction depends on. When two opposite faces of a slab, each of area of cross section A and is separated by a distance x, are maintained at temperature T1 and T2, where T1 is greater than T2. Temperature of T1 is greater and temperature T2 is smaller. Then the amount of heat that flows in time T, Q equal to Ka T1 minus T2, small t upon x, where K is the coefficient of thermal conductivity of the material. The rate of flow of heat through the slab is given by del dq upon dt equal to minus k dt upon dx, where dt upon dx is the rate of fall of temperature with distance and is called temperature gradient. dt upon dx is called temperature gradient and it is the fall of temperature with distance. Coefficient of thermal conductivity. Coefficient of thermal conductivity. It may be defined as the quantity of heat energy that flows in unit time between the opposite faces of a cube of unit side. The faces being kept at 1 degree different of temperatures. The thermal conductivity of metals are much greater than those for gases. Gases are poor thermal conductors. Heat current and resistance. What is heat current and resistance? The flow of heat per unit time is conduction, is called heat current. The flow of heat per unit time in conduction is called heat current. The ratio of the temperature between the ratio of the temperature difference between the ends of a conductor to the heat current through it is called thermal resistance. Heat current H equal to Q upon T, and that will be equal to Ka delta T upon dx. Thermal resistance RH equal to delta T upon H, or it can be written as delta X upon K. Convection. What is convection? It is the process by which heat is transmitted through a substance from one point to another due to the body motion of the heated particles of the substance. Fluids are mainly heated through convection. Natural convection arises due to the unequal heating and gravity. When more heated and less dense parts rise and are replaced by the cooler parts of the fluid. In forced convection, a material is forced to move by an agency like a pump or a blower. Radiation. What do you mean by radiation? It is the process by which the heat is transmitted from one place to another without heating the intervening medium. Prevost's theory of heat exchanges. I am telling about Prevost's theory of heat exchanges. All bodies emit radiations irrespective of their temperatures. They emit radiations to the surroundings and receive radiations from the surroundings. In the equilibrium state, the exchange of energy between a body and its surroundings occur in equal amounts. Now I am moving to the next topic, thermal radiation. What do you mean by thermal radiation? The electromagnetic radiation emitted by a body by virtue of its temperature is called thermal radiation or radiant energy. Thermal radiations are electromagnetic waves of long wavelength ranging from 1 μm to 100 μm. Absorptive power of absorptivity. absorptive power or absorptivity. It is denoted by A lambda. The absorptive power of a body for a given wavelength lambda is defined as the ratio of amount of heat energy absorbed in a certain time to the total heat energy incident on it in the same time within a unit wavelength range about the wavelength lambda, and it is a dimensionless quantity. Now, emissive power E lambda, it is denoted by E lambda. The emissive power of a body at a given temperature and for a given wavelength lambda is defined as the amount of radiant energy emitted per unit time per unit surface area of the body within a unit wavelength range around the wavelength lambda. Emissivity. I am telling about emissivity of epsilon. It is the ratio of the emissive power of a body to the emissive power E. It is the ratio of emissive power of a body small e to the emissive power capital E of a black body. Capital E means what? Emissive power of the black body at the same temperature, and it is given by epsilon equal to small e upon capital E. The emissivity of black body is 1. Now I am moving the next topic, black body. What is black body? A black body is one which neither reflects nor transmits but absorbs whole of the heat radiation incident on it. The absorptive power of a black body is unit. Now I am telling about Kirchhoff's law. What is Kirchhoff's law? It states that at any given temperature, the ratio of the emissive power E lambda to the absorptive power A lambda corresponding to the certain wavelength is constant for all bodies, and this constant is equal to the emissive power of the perfect black body at the same temperature and corresponding to the same wavelength. I am repeating once again the statement. It states that at any given temperature, the ratio of the emissive power small e lambda to the absorptive power capital A lambda corresponding to the certain wavelength is constant for all bodies, and this constant is equal to the emissive power of the perfect black body E lambda at the same temperature and corresponding to the same wavelength. E lambda upon A lambda equal to capital E lambda. Capital E lambda is constant. Hence, a good absorber is a good emitter. Stephen Boltzmann law. What is Stephen Boltzmann law? It states that the total amount of energy radiated. It states that the total amount of energy radiated per second per unit area of a perfect black body is directly proportional to the fourth power of the absolute temperature of the body, and it can be written as E directly proportional to capital T to power 4 or E equal to sigma T4. Sigma is called Stephen's constant and its value is sigma equal to 5.67 into 10 to power minus 8 W per meter square per Kelvin 4 per Kelvin to power 4. If a perfect black body at temperature T is placed in an enclosure at temperature T0, then the net amount of heat radiated per second per unit area by the black body is given by E equal to sigma T4 minus T04. If the body and the enclosure are not perfect black bodies and have relative emissivity E, then E equal to sigma yes, equal to sigma epsilon T to power 4 minus T to power T0 to power 4. Newton's law of cooling. What is Newton's law of cooling? For small temperature difference between a body and its surroundings, the rate of cooling of the body is directly proportional to the temperature difference and the surface area exposed. I am repeating once again the statement. For a small temperature difference between a body and its surroundings, the rate of cooling of the body is directly proportional to the temperature difference and the surface area exposed. This is known as Newton's law of cooling. dt upon dt equal to minus Ka T minus T04. Wiens displacement law. What is Wiens displacement law? It states that the wavelength lambda m, corresponding to which the energy emitted by a perfect black body is maximum, is inversely proportional to the absolute temperature T of the black body. I am repeating once again. It states that the wavelength lambda m, corresponding to which the energy emitted by a perfect black body is maximum, is inversely proportional to the absolute temperature T of the black body. Lambda m is directly proportional to 1 upon T, or it can be written as lambda m equal to B upon T, where B is constant of proportionality and is called Wiens constant, and its value will be B equal to 2.9 into 10 to power minus 3 meter Kelvin. Solar constant. What is solar constant? It is defined as the amount of solar radiant energy that a unit area of a perfect black body on the earth would receive per second in the absence of the atmosphere, with its surface perpendicular to the direction of the sun rays. I am repeating once again the statement. It is defined as the amount of solar radiant energy that a unit area of a perfect black body on the earth would receive per second in the absence of the atmosphere, with its surface perpendicular to the direction of the sun rays. Its value is 1340 watt per meter square. Surface temperature of the sun. What is surface temperature of the sun? If S0 is the solar constant and Rs is the solar radius and R0 is the mean distance of the earth from the sun, R0 is the distance between earth and sun, then the solar surface temperature of the sun will be T equal to R0 square S0 Rs square sigma under the bracket whole power 1 upon 4. If you like my video, please like and subscribe my channel. Thank you.